Hey class, Adrian here. Let's relieve some tension by working on homework number 7, that's module number 7 on Pearson. This is number 12, where we have 3 ropes tied in the fashion shown in this image here. I'm going to select this point right here in the middle as my frame of reference. Notice that I've already gone ahead and drawn the tension force vectors, T1 pointing to the left and up, T2 pointing to the right and up, and then T3 pointing to the right and down. The first thing you want to do in these sort of problems is break down these vectors into their horizontal and vertical components. So T2, for example, this one, would have a vertical component going up and a horizontal component going to the right. So I could call this one T2x and this component T2y. Right, if you do the same thing for the rest of these vectors, T1 has a horizontal component that goes like this, T1x, and a vertical component that goes upward, which I can call T1y. All right, finally T3 has this horizontal component, which I'll call T3x, and this vertical component, which is T3y. All right, now let me change color here. What you're gonna wanna do next is set up a system of equations. The first thing I'm gonna do is start off with the sum of all the forces in the x direction. That's equal to the mass times the acceleration in the x direction. Well, hey, there is no acceleration. The right-hand side is 0. So we have that the sum of all the forces along the x direction have to equal 0. In other words, all these tension forces must balance each other out. We're not told that anything in this problem is moving, so we're assuming there's no acceleration. So to expand on the left-hand side of this equation here, I'm going to add together all the forces in the horizontal direction. So I'll have T1x, so minus T1x. Why is it negative? Because it is pointing to the left. And then I'll have plus T2y. T2x. That comes from up here. That's this component pointing to the right, which is why I put a positive there. And then finally, I'm going to add T3x because that's also pointing to the right. T3x is equal to 0. Okay, now we want to use trig functions to figure out what these components are in terms of their magnitudes and some trigonometric function. So for example, T1x here is the side that is associated with the adjacent, so T1x here is the side that is adjacent to my angle, and we are also given the hypotenuse, that is the magnitude T1. So I can use the cosine function there. So T1x can be expanded as T1 magnitude, which we're given in this problem, times the cosine of 45 degrees. T2x component is the side that is opposite my angle, right? It's the opposite side. So I know I'm going to use a sine function, T2 sine of 30 degrees. And then finally, the x component of tension 3 is over here. It's the side that is adjacent to this unknown angle. So I will write magnitude T3 times the cosine of theta. That is equal to 0. Okay, so I'm going to box this equation here. Box it up real nice. It's going to serve as a present later. And then we start off with the same procedure, now doing the sum of all the forces in the y direction being equal to 0. Okay, so over here, I'll try to speed this up. We have T1y. It's positive because it points up. T2y is also positive, and then T3y is negative. So plus T2y minus T3y is equal to 0. And then we expand these terms into trigonometric functions and magnitudes. So T1y would have to be magnitude T1 times the sine of 45 degrees plus T2y, which is the magnitude T2 cosine of 30 degrees. Let me scoot this over to the left here. And then we have minus T3y, which is magnitude T3 times the sine of this unknown angle, which is equal to 0. Does everything check out here? Yes, it does. And then I just want you guys to notice that whether you're talking about horizontal or vertical components, there is no one trig function you stick to. So for example, many people think that because you have horizontal tension here, these horizontal components are associated with the cosine function, but that's not the case here because of the geometry, right? All I'm trying to say is don't associate the cosine with horizontal components, and don't do the opposite for vertical components, right? Vertical components aren't always associated with the sine function. All right, anyways, I hope I haven't gone on too long, but here's the other equation. In these problems, you are given magnitude T1, magnitude T2, and you are not given T3. You're not given this angle. You're given this. This could be plugged into a calculator. Oh, this 2 and then this 2. T2 is given. This is a calculator value. You are missing T3 and you're missing theta over here. So you should be able to put these two equations, equation 1 and equation 2 together, to solve for either theta first and then solve for T3, or you could solve for T3 first and then solve for theta. Actually, I take that back. I'm not sure which one you have to do first. Just experiment with equation 1 and 2 and see what you get. Please email me if you get stuck, and happy studying, guys.